Uh, okay, welcome everyone. Thank you for watching our presentation on designing a composable API platform powered by open standards for API Days Paris 2024. So at Tyke, we believe that you should be able to work with the tools that you want to work with and not be hampered by vendor lock-in and should be able to use open standards. So that was kind of the background behind this talk today. I am Sophie. I'm head of product at Tyke. I've been with Tyke for 5.5 years now. So I'm generally looking at the overview and state of the API management market and the needs of our users and customers. And we've got Carlos with us today as well.
Hello, I'm Carlos. I'm a solutions architect here at Tyke, and I am going to help showing you a couple of things and demos around composable platforms for APIs.
Thanks, Carlos. So the agenda for today, we are going to be looking at the need for API platforms, the need for composability and open standards, and then designing a composable API platform. And then, as Carlos mentioned, he's going to be doing a demo around how we actually build a composable API platform. So I want you to think about now kind of how many of you watching are actively designing and developing APIs. I think probably a lot of you, most of you watching this. And how many of you kind of actively feel that you manage that development as well? So you observe and you govern the platform. Hopefully a lot of you as well, but maybe not so many as you who are actively designing and developing. So just going to talk about the need for API platforms now. APIs are everywhere, as you can see from this data. We use APIs day in, day out. And it's the reason that we all at a conference like APIs Days Paris. 71% of all web traffic in 2023 was API calls. And the typical enterprise in 2023 had 1.5 billion API calls last year. But there is the tech and there's also the processes and the people. Building APIs is hard. And the tech should be the easy bit, and it's the people and the processes that are often the difficult bit. So it's not just about building the functional logic. There are security, governance, observability, discoverability, developer experience, consider, as well as managing the distributed teams, involving the business needs and expanding the tool stack. So there's a lot involved here. Here is a definition of API platforms that we've found. A platform that enables developers to build and manage API products better, faster, and more efficiently. We feel like this tool, this description is a bit tool-centric, very tech-centric, and it doesn't really focus too much on the people or the processes. So here is a different description, a different definition that we've come up with, focused more on what we feel really matters, being able to deliver the desired outcomes. So a composable ecosystem of intentionally designed APIs that empower developers, partners, and consumers to deliver desired outcomes. So it's empowering everyone in the lifecycle. API platforms should be collaborative, and composability is important too. So development lies at the heart of these platforms, and we have to layer in what makes the development run as smoothly as possible. The operational side, the governance aspect, and the discoverability and consumption of the services being created. The development needs to be empowered within the boundaries of the organizations. So now let's talk about why we see composability and open standards as a key part to building out API platforms. If we go on a journey here, over a decade ago, API Days was actually founded around 12 years ago. So this was probably the state of the enterprise API development and platform management back then. Likely a very small team, monolithic, not very much complexity, a small user base, single product and easy deployments. But things then get bigger as we go through time. People might dive into microservices, breaking up the monolith. Then you may have grown through acquisitions, moved into the cloud to get closer to your service consumers, moved into multi-channel or multi-protocol solutions, And security matters more and more as your surface area has grown. All of these things are what starts to happen as your API landscapes and API ecosystems grow. So what that all boils down to really is that these enterprises, teams, systems, and APIs have all grown, and the complexity has built up as well. It's hard to discover APIs. There's a lack of visibility. There's a high surface area for attack, higher risk. It's hard to troubleshoot issues, maybe because you don't even know about these potential issues. And there is no standardization or governance across distributed teams. And the biggest issue, I think, of all of these is scale. Increased complexity, scale, and if these problems exist at a small scale, they are magnified as growth happens. And really, you are paying for your own success. So yeah, it would be interesting to know whether this resonates with you as you're listening to this. This might come to mind. You might feel like this sometimes. If you directly are not feeling like this, I can guarantee that there are probably people within your wider organization that might do. So the need for composability now. So the choices you make when you're starting off seem simple. As things grow, you need to evolve your systems and tooling so that decisions you make really matter. You have to balance flexibility with complexity. You might be having to build the build versus buy debate. You want to avoid vendor lock-in. You want to ensure your decisions scale with your business so that you avoid having to replace and start over again. Composability powered by open standards could be your solution to fixing a number of these issues. So how can we design a composable platform that works for all the people that are involved in the platform thinking? There are 3 areas really to focus on. So we've got strategy and metrics, implementation for future proofing, and evaluation and iteration. On that first area of strategy, we are thinking about what metrics we want to move the needle on. So take a moment to think about what metrics you measure, and we can talk about some of those now. So there are productivity metrics. This can encompass a lot of areas. So how do we enable developers to build in the most efficient way? How fast can they find APIs, build APIs, not duplicate APIs, troubleshoot APIs? We think about deployment times, release cycles, developer velocity. All of these sorts of things count towards productivity. We then think about cost savings. We're thinking about standardizing to specific tools, and that then will lower the cost of tooling itself. But not all of the productivity metrics that we spoke about also indirectly lead to these cost savings as well. And then the last point here is around developer happiness. You can think about tracking things like your internal NPS, your developer turnover. These things will help you understand what good looks like from a platform perspective. And then we need to think about the implementation. So we do not want to be prescriptive about technologies and tools that you use. The whole point is that you fit in the tools and compose a system that works for you. So if we go back to the issues around complexity that we already discussed, there are standards and open source tools that help solve these directly. So the composable API platform capabilities really are around discoverability and design, security, observability, and centralized governance. And the tools that support these, the open standards that support these, we've got Open API Spec, we've got different developer portals, we've got OAuth and identity providers for security, we've got open telemetry if we're thinking about observability, and we've got things like open policy agent when we're thinking about centralized governance. So there is a correlation between the items we can do to think about composability and open standards and how to fix some of the issues around the complexities of platforms with open standards. And if we bring it all together, what we're looking at here is a composable API management tool that lets you bring all of these tools and standards together and lets you manage and view it all from one place. And then the final thing you have to do when you're thinking about a composable API platform is the evaluate and iterate phase. So this is where it comes back to the people and the processes side. So you need to open the channels with those who are part of your platform ecosystem, work with them to figure out what is working, what isn't, and how to get better and evolve. And if we think about what success might look like, this data shows what key metrics look like for teams that haven't adopted these platform best practices yet. We're looking at long release cycles, slow deployment times, and a lot of money spent on keeping everything alive. And with a composable system and open platform, we're looking at faster release cycles down to weeks. We're looking at deployments in minutes rather than hours and weeks. And we're looking at vast cost savings across toolings and management. We have customers who have saved well over $100,000 by moving to a more composable open standards platform. So how do we actually build this? Over to Carlos to walk us through.
Thank you, Sophie. So, okay, I'm gonna move now to my screen and my demo environment. So I'm gonna start by showing a diagram of what a composable platform for your APIs would look like. Sophie was talking about different microservices. It was talking about how agile, composable. It was talking about avoiding vendor lock-in. Well, the diagram that you see here is full of open standard, mainly with microservices, and it allows you to have the state of the art of a composable platform. Starting from the right, from the left down, we're going to see API developers that are going to start using what's called OpenAPI. I'm pretty sure OpenAPI is something that you're familiar with. Basically, a specification that allows you to have open API define an specification of an API that is always going to be there, is going to be living, and you're going to be able to change and adapt. Of course, that open API specification is going to be stored, for example, in a Git repository for you to use. Then, if you look a little bit closer to the middle, we're starting to see other parts of the platform, like the gateway, which is the way that people are going to be accessing to the different microservices. Of course, everything needs to be secure, and this is why we have another tool. Pretty sure you're familiar with it. It's called Keylog. Keylog is a tool that allows you to secure those APIs. How? Well, mainly because it has the possibility of creating what is called JOTs. Of course, when everything is done and you have your API settled and you start to use your gateway and you're able to get and hit your services, you want to monitor that. And here, there's other tools that allow you to do that. And when you look at this diagram, for example, of course, we're from Tyke, but you could use any other tools in order to compose this platform. But what you're seeing here right now, it might look a little bit confusing or complex. So let's start from the beginning, and let's start with how a developer journey starts. So if I go now to what is called the Tyke dashboard, right now here you can see how everything is empty. There's no APIs loaded. So what I want to do first is to load an actual API. And I want to hit one of our proxies. Well, actually it's called HTTP bin. So I want to get and hit one of the endpoints. So in order to do that, I'm going to be importing one of my OpenAPI specifications, which is this one in here. If you're not familiar with it, an OpenAPI specification is basically the description of how an API should work, including endpoints, including where the server is located, so you can access to those, right? This one is, of course, Apidays one. So now, if I come to my dashboard, I can actually import this. So I can import it from file. Of course, if you have it, normally you will have it in a Git repository, so you want this to be automated. But for now, I want to show you how it will be done manually, and then we can see it, how it can be automated. So I can, for example, put here where I want to hit this API with a listening path. So I can import this. And then if you see here, I imported that API. You can see how it was the target URL imported. and all of the information and also the endpoints, right? So this is something that is important. You want the tools to speak that specification to be integrated with those open standards as open API. Now, of course, you will say, right, okay, now what? Like, how do I hit this endpoint? Well, if I go to Postman, for example, you could use any other tools. I already have this written. My gateway is actually in port 8080. And if I click send, it is going to be hitting and getting that data, that information that you saw before, right? This information, this body. Now, of course, this is prompt to error, right? We're looking at the possibility of doing what is called ClickOps. So basically, I imported manually everything, which is definitely prompt to error. So something that we want to look at is, and let me go and move to the next diagram, is for this to be automated. Now, you're going to have an API developer that has developed an open API specification or description, and this is going to be stored in different manifest and CRDs from Kubernetes. And then we're going to be using an operator. This is called the tag operator, but it could be a Kubernetes operator that can ingest that CRD and then pushed into the gateway. Now, there is another thing here, which is called Open Policy Agent. I'm pretty sure you're familiar with this. And this Open Policy Agent is going to be allowing to set rules to those APIs that are being ported into the gateway. This is very important. Why? You want to standardize. You want to have a govern. You want people to not think if the API is secure or not. Why? Because you want the gateway to do that. You want the gateway to automatically be able to secure your APIs. But in order for the gateway to understand what they need to do to secure it, you can do and add some policies. Now, of course, if you want to secure that API, we need a tool that allows you to create JWTs or JSON Web Tokens or bear tokens, however you want to secure it. And of course, in order to get those tokens, you need to have a flow. And this is interesting because there are already flows out there that are made as a standard. So for example, you can use OpenID Connect with Auth 2.0 flow. So in this case, an API consumer can get a Joe token from Piclo. Okay, now I'm pretty sure you want to see how this works. In order to make this flow happen, to inject that information there, we can what is called apply some CRDs and manifest into Tyke and into Kubernetes. So if I go 1 second to this demo on our, actually our demo repository. So the demo that you're seeing right now, everything is in a demo repository from Tyke. If you actually want to play around with this, you can. It is actually very simple. You just need to have a license that we can provide that license. Everything is deployed in Minikube, so you can actually use Minikube to do that configuration. And also, we're using Argo CD in order to deploy this different systems. And of course, I'm going to have to refresh this. So as you can see, we have the entire environment deployed in Argo. You can see the different boxes. You can see how it was deployed using Helm charts and all the different means. So the cool thing around this is that not only you can automate how you import the APIs, but also you can automate how you can and how does your complete environment infrastructure look like. This is basically deploy everything Argo CD. Now, if I will go to deploy, for example, more examples of APIs, as I mentioned before in the diagram, I can click on examples. In here, there are different examples. There are, for example, users, which we're going to be focusing on, or there's HTTP bin, but injecting via a CRD. So if I go, for example, to this Open API specification, you can see that this is a very similar one that what we saw before. It's an open specification with some endpoints, right? And then we can have an application, which is basically our custom CRD that is going to make the Tyke operator understand what they have to inject, right? So if I go back to my application, you're going to see here all the information, what you need to inject, and it is actually also going to create the services with some standard manifest from Kubernetes. Okay, so let's do that. If I go to my terminal, which is in here, I can actually import this with a simple command, which is apply, and everything is in a local example folder that I have imported into my system for this demo. Here, you're going to see this is called K9X. Basically, is a tool that allows you to see all the different nodes and pods that you have in your system. So you'll be seeing some services being created. So if I click examples, it's going to start creating some resources. So you can see how also the services are being created here. We're also using K6 in order to generate traffic for the demo. So if I go back to my dashboard now, and I'm going to start moving to the dashboard here, in the overview, I can see how many different services were created, APIs were created, which are actually proxying to those services. And also you can see how traffic was starting to be generated. So if I go to my APIs, for example, if I click on users, we're going to see that some information was added. And one of it was that I want to access to this API via Keycloak, which is my JSON or my identity provider. How does Keycloak look like? Well, Keycloak is basically an open source tool that allows you, open source and free tool that allows you to do some of this administration of your different tokens. For example, if I look into users, I have an admin user, a developer user. The cool thing about Keycloak as well is that you can import and export all the specifications, so all the information that you have here into a YAML file, into a CRD, and you can use it later on in order to import it into your architecture. For example, using Argo CD, something that we saw before. Right. If I would like to access, for example, to one of my APIs, the one that is called users, I know that the path from this is users. So now if I go back to my Postman, and I'm going to close this window now. If I go back to my Postman, I can use, for example, this endpoint, which is the one from the gateway. Here, and I can say users. And for example, I can look for user number 2. And of course, it's going to tell me that authorization file missing. It means that I need to add some kind of authorization header. So if I go and I add authorization, now if I click send, it tells me there's still file missing. So if I put some information, I click send, key not authorized. So I need to get one key. So if I go to my administration token in here, I can see how I'm using, for example, the username, admin example, as we saw in Keycloak, and I have a client ID and a client secret in order to get those Joe tokens. So if I click on send, it's going to generate a new access token for me to use. So I can copy and paste this. And if I go to my users endpoints and I click and I add this, I click send, of course, I'm going to get some information. And this is interesting because basically what I did with just one command line, which can be automated, is importing all the information from a Git repository, or in this case, a local system, and it created automatically an API definition with even all the security needs for that API definition. Now, something I didn't mention is that API definition didn't have by default the part of Keycloak. And this is something that you can do with Open Policy Agent. And this is something that we have added, for example, as a patch request. So if there is a metadata called Keycloak inside of the API definition, I will not get into many more details, it will create for you that information and it will assign the different things they need to know. For example, the policies, it will add also the default policy needed and the source of the Keycloak, right? So that is something that is interesting to to know, because basically what you're doing is assigning policies and rules. So you're standardizing those APIs, and you are reducing any kind of errors that people can do when designing their APIs. And of course, we're talking about activity logs. We can check information around logs in here. I'm going to put it so we actually see information, and you can see how there are different requests being done. But of course, this is information that you can see from a dashboard that is proprietary to Tyke. But the cool thing around our implementation, if I go back to my diagram, is that also all that information can be exported to different tools. Like for example, using the Tyke pump, we can send information to Prometheus, all the different metrics of all the different requests that are being done. And then you can also use traces in order to send data via OpenTelemetry to, for example, Grafana Tempo. Or you can also use the Tyke Gateway to put all the logs into the stood out logs. And then those logs will be consumed by Grafana Loki. So how does this look like in Grafana? Actually, I forgot one very important thing. When you have the gateway sharing traces, you also want to have your services sharing traces. And why is that? Because the traces are going to be telling a story of how the request was done. So you're going to understand where the bottlenecks happen. So if I go now to, for example, Grafana, and I go to API observability, I can see here some information about the requests that are being done. K6 was doing that for you. The duration per spike name, also the P90s, or even requests being done by the different gateways, right? This is in the last 30 minutes. You can, if you want to see something a little bit more concise, you can do, for example, the last 5 minutes, and you can see how this is dynamically moving. And this is all around metrics, right? But if you want to see, for example, the other part, which is around SLOs, you can actually do that too. But what I was going to is, if you want to do or check, for example, the information from your traces, you can do here, and you can check in Tempo. And if you do, for example, search, you can see how the different requests were being logged. But the cool thing around this is that if I click in one of the traces, you're not only going to see the information from the traces from Tyke, but also the ones from the user service. So you can see how the get was done. You can see how we were checking information into and understanding if key clock was allowing to access. In this case, it was one of the longest times. Well, actually, the get was around a millisecond, and then the user get service to provide this information, it was 72.7 micro seconds. That's pretty nice, right? This is a very good understanding on how things are being done. And of course, I really liked, for example, Jagger, because it also allows you to do allows you to get some information from the traces. So if I click find traces, same thing we did, right? This is the request that we did. We can see the jot middleware, how it was able to call key clock, and also the jot service, the user's rest service. And all this because at the end you have a trace that you can pass on. So in a nutshell, what did we see? We see how you can have an open API specification in a Git repository on a local system that you can expose into your Kubernetes namespace. Then an operator is going to pick it up, is going to inject, and is going to put some policies so everything is standardized. Then you have the gateway that is going to allow all these requests to come in from API consumers. Of course, that API consumer needs to be allowed to be accessed. And then you're going to have all this monetization happen in the gateway, right? That you want to export different tools. So you can have the full picture of how the request is being done and also how your system is working. So I really hope you liked the demo. And yeah, if you have any questions, you can actually write it in the YouTube video, or if you have any other things that you want to discuss, let us know. I'm going to pass it back to Sophie so she can close the workshop.
Thanks, everyone. Yeah, as Carlos says, if you have any questions, please post them directly in the comments and we will get back to you. Thanks so much.
Thank
Bye.
you.